Abhishek, this is for BPSC assistant professor, right?
Yes, ma'am.
Okay. Abhishek, please you just tell me about yourself first.
My name is Abhishek Kumar. I belong to Patna, Bihar. I have completed my Bachelor of Technology in Electrical Engineering from IIC College of Engineering and Technology, Greater Noida. I have completed my Master of Technology in Power Electronics and Drive from NITIE Allahabad in 2019. And currently, I am working as a guest faculty in Government Engineering College, Lakhisarai, whose classes are currently running in the GEC Jamui in Bihar only. And my hobbies are to listen and sing songs and cooking.
What are your hobbies?
Listening and singing songs and cooking also.
Okay, fine. So you're working as a guest faculty, and how many years you're working since then?
Ma'am, from past 2 years.
2 years. And what are the subjects you're teaching?
Since my specialization is in power electronics, so I take the classes for the power electronics and the measurement also, EMT, and some machines also, network theory like.
So what has been your experience so far? Like how it has been there? You were comfortable in teaching the students, and how did you feel like you were comfortable?
Yes, ma'am, I am pretty comfortable in teaching the students. So there is no such like a burden. But initially, because due to the lack of the experience, I faced some difficulties, but now I am just okay with all this.
Okay. Abhishek, why you always wanted to go for teaching? Like if it is that's the case, any other profession you thought of?
Ma'am, it all depends upon the opportunity also. But as my interest in the teaching, it developed since I was in school days. Since my school days only, my teachers used to appreciate me that Abhishek, you explain the things well. They used to call me on the board and ask me to just explain anything. And in my college also, when I used to give presentation for the projects, so my teachers used to appreciate me regarding this. So this drive my interest toward this career.
Okay, so you think you're good in explanation and all that?
Yes, ma'am. Yes, ma'am. My teacher used to just compliment me like this, so that driven my interest towards this.
Okay, and can you just tell me like 3 of the qualities which you think are there, which makes you a very good teacher? One is you told about explanation and all that.
Ma'am, any teacher, I'm not specific to my only. Any teacher that he or she is good in teaching, that he must possess a good knowledge of the subject. The subject that he or she is teaching, he or she must have the good knowledge in that. The second one is that he must be able to explain that to the audience, or especially the student must be able to grab the things that is someone delivering to them. So this one quality that one teacher may possess. And the third one is that the good communication skills and your relationship with the students is also very important. That whether your student is listening to you, whether they are just giving respect to you or not. So these all qualities must be in a good teacher.
Okay. Abhishek, you told me like these are the very important qualities which need to be there in a good this teacher. Can you just tell me where the students actually lack? Why our Bihar students are generally going outside? Like they do not drift towards their state, they move outside. What is the reason?
If I just look at the reasons for the migration of the students in other state colleges, like first of all, there were in the initial days, from the past 4 to 5 years, the infrastructure has got developed. But before the 4 to 5 years, there was no such infrastructure in the colleges. There were the colleges, but the infrastructure were not good. And since most of the colleges in the very remote areas, still in Bihar, if I just talk about the Patna or the other cities like Bhagalpur or the Gaya, the colleges are situated within the city, but in other districts of the Bihar, the colleges are very much in the remote area that rarely any company will visit there. So these are the problems that the students are facing. And most of the students are also facing like they don't find the peer group to develop themselves because they lack, most of the students lack in the communication, they don't speak the English well. So that's why they also want to migrate to the other states so that they get the diverse students from the students for the different states so that they can able to develop their activities and the other things, personality development.
Okay, fine. Abhishek, you just told me what are the problems in it. You have not done PhD, right?
No, ma'am. Currently, haven't done.
You have just done your master's, M.Tech.
Yes, ma'am. Yes, ma'am.
Okay, so why didn't you go for this PhD? Like, don't you think PhD is very important to teach the students?
Yes, ma'am. I think the PhD is very important to teach the student. But if I just say my the personal reasons of joining the as a guest faculty was the financial issues of my family. When I have passed in 2019, in the very next year, my father has got retired. So in order to support my family financially, I had to join the as a guest faculty. But in the recent future, whenever I will get the opportunity, I will surely go for the PhD also.
So do you think that PhD is very important to teach the students? Only a PhD candidate can be a good teacher?
It is not like that only a PhD candidate can be a good teacher, but yes, being a deep analysis of some subject matter, he or she is teaching must be there. So PhD is necessary, but not is the only qualities that must possess by the teacher.
Okay, fine. And you just tell me one thing, Abhishek, like what has been your area of strength and weakness?
If I talk about my strength, that I am calm and I can explain the things well. As a teacher, I find this one of the most important feature that I possess. And about my weakness, I tell I'm a little bit more emotional, so I flow in the emotions. So these are the some of the
So what are you doing to overcome this weakness? You're like emotional, so there would be very important things which come in life, and you need to deal with it very strongly and efficiently.
and there is no such major step that I would take, but I deal with it. There is no such problem in it.
Okay, something you've not learned how to deal with it. There's nothing, no measure as such, right?
Yes, ma'am.
Okay. Like you have been working since last 2 years as a guest faculty. So what are the traits you have learned over there? What are the things you think that that job has actually taught you?
Uh, First of all, ma'am, if I talk about my initial days, I could not handle the mass of the students. But now I am able to handle them. Most of the students are a little bit notorious in the class, so we have to deal with them also, so that the other students who are actually serious in attending the class must not suffer. And, and these are the things that I have learned in.
And one more thing, like what has been your contribution to the nation so far, Abhishek?
Uh, as a nation, my contribution toward the nation is just that I am teaching to the students, so I am just contributing in the building the future generation, man. I'm just teaching them. So of course, when they will just pass out from the college, they will contribute to the nation in the development of the nation. So indirectly, I'm also contributing to the development of the nation in that.
Okay,
I'm
fine. One
shaping the
last
future
thing.
minds.
Okay, one last thing. Like Abhishek, can you just tell me and sum up all of this interview in one word, like the personality you have? What will be the best word you will choose for yourself?
Uh, I'm not getting the right word for.
You need to use yourself for one word for yourself. Like what kind of a personality you are?
Dynamic, you can say, ma'am.
Dynamic. Okay. Now you can go for the technical round and then we'll
Thank you.
sum up this
Thank you,
interview.
ma'am.
Okay. Take care.
Thank
Hello, sir.
Good afternoon, sir.
Good afternoon, Abhishek. Okay, you teach there power electronic, electrical machine and
Measurement EMT also, sir. So sometimes
measure.
network.
Okay. अच्छा measurement में what is the difference between accuracy and precision?
Sir, accuracy means how much the measured value is close to the actual true value. It's just given by the accuracy. And the precision means that if we must make the repetitive measurement, then each of the measured value is how much close to each other. That is given by the precision.
Okay. So can an accurate may be precise or a precise instrument may be accurate?
Sir, any accurate, sir, if an instrument is accurate, then it does not mean that it will be precise. And if it is precise, then it does not mean that it will be accurate only. Uh, a precise instrument may not be accurate, or an accurate instrument may not be a precise also.
Okay. Acha, one more basic question. What is the must be the basic property of an instrument?
It must give the measurement very close to the accurate one, and it must be the precise also.
Basic property regarding loading effect.
The loading effect of the instrument is, sir, whenever we connect an instrument, the error arises due to the loading effect. So any instrument, the loading effect must be less, so that the measured value is accurate enough.
हाँ, तो यहीं से उसकी basic property arrive होती है कि it should not alter the circuit condition in which we are using. Okay. We have to measure power of three-phase circuit.
Yes, sir.
Which method will you suggest?
The power can be measured by using the wattmeter. So first of all, we have to decide that whether the three-phase circuit is a symmetrical or unsymmetrical. If the three-phase circuit is symmetrical, then it can be measured by only a single wattmeter. If by single wattmeter, we can measure the power in a single phase circuit, and we can just multiply it by the 3 to get the overall three-phase power. But if we have a unbalanced three-phase circuit, then in such case, we can use the 3 wattmeter method or the 2 wattmeter method. But generally, we don't use the 3 wattmeter, we can use the 2 wattmeter method.
Okay. Can we measure the power factor of unbalanced load using 2 wattmeter method?
Yes, sir. We can measure the power factor of the unbalanced load.
Unbalanced. Yes. Can you tell me the formula?
Sir, if the 2 wattmeter, if the wattmeter readings in the 2 wattmeter method is W1 and the W2, then the tan pi is given as a 3 root 3 P1 minus P2 upon P1 plus P2.
Which phase power factor it is? Because we have unbalanced load.
Which? Sorry, sir, I'm not getting it right now.
Okay. We can measure the power factor only for balanced load, not for unbalanced, क्योंकि तीनों phase में different होता है. ठीक है?
Okay, sir. Thank you.
अच्छा, now tell me, you are studying teaching electrical machine also.
Yes, sir.
ठीक है?
Yes, sir.
What is the critical resistance for DC shunt generator?
So for the critical resistance is the maximum value of the resistance below which the shunt there will no any generated voltage. If we will lower the resistance value below this critical, sorry, if sir, it is the maximum value above which the generator will not give any output voltage. So that is defined by the critical resistance.
Critical resistance.
Yes, sir. Sir, it is the maximum value of the shunt resistance above which the generator will not give the output voltage.
इसमें कहीं पे इसकी डिपेंडेंसी डिपेंड्स करती है स्पीड पे?
Yes, sir, it will depend upon the speed.
तो स्पीड का टर्म तो आपने बताया नहीं डिफाइन करने में.
At the rated speed, sir.
At the given speed.
At the given speed, yes, sir.
Okay. Why we use a differentially compound generator for welding purpose?
Sir, actually the welding is a phenomena in which the two metals are joined, and during the welding there is a condition of the short circuit. So whenever the short circuit occurs, if we will use the normal generator then the high current may flow and it can damage the system. But in differentially compound generator, we see that its characteristic is grouping so that the voltage at the high current is very less. So if the voltage at the high current will be less, then during the weld, when the short circuit occurs, the current cannot go to the high value.
Okay. So can we say that machine is self-protected machine?
Yes, sir. It is a self-protected machine.
अच्छा, ठीक है. We have a DC series generator of 220 volt, 60
Yes, sir.
kilowatt.
Yes, sir.
220 volt, 60 kilowatt,
Yes, sir.
3000 RPM.
Yes, sir.
ठीक है. We run this generator at no load at rated speed.
Yes, sir.
So what will be the terminal voltage approximate?
Sir, if the DC series generator is run at the no load, then the terminal voltage will not be there. It will be very small due to the residual flux.
Very good. Okay. We have two methods of speed control: armature control and field
Weakening control.
excitation control.
Yes.
Which method is constant torque drive or which method is constant power drive?
So the field weakening method of the speed control is a constant torque drive, and the armature resistance control is the constant power, variable power, and the variable power drive.
Armature wala variable power, variable torque?
No, sir. Armature is the variable power constant torque, and the field weakening control is the constant power variable torque.
Okay. Okay, which are the method of starting for induction motor?
So the starting for the induction motor, the method that employs are the star delta conversion technique, auto transformer technique, the resistance control technique. So these are the methods.
Actually, in DOL we have under
Yes, sir.
voltage protection. Starters में under voltage protection लगाते हैं.
Yes, sir.
What is the purpose of that under voltage protection? क्योंकि हम तो स्टार्टिंग में ऐसा कर रहे हैं कि वोल्टेज लो देनी है जिससे कि करंट कम हो. क्या मतलब है?
So right now I'm not getting it.
ओके. और कौन सा सब्जेक्ट पढ़ाते हैं? पावर सिस्टम.
No, sir. Power electronics.
पावर इलेक्ट्रॉनिक्स. अच्छा. पावर इलेक्ट्रॉनिक्स में एक 3 फेज हाफ वेव रेक्टिफायर, ठीक
Yes,
है,
sir.
विद डायोड.
Yes, sir.
उसका वेव डायग्राम बना के मेरे को दिखा दो आउटपुट.
Okay. Okay, sir. It is like this.
ओके. what is the conduction period of each diode?
So the conduction period of each diode is 120 degree.
120. And PIV?
The PIV is a VM,
VM of what?
or supply voltage, line to line VM voltage.
Okay. Okay, Abhishek. Now, sir, will take for further.
Thank you, sir.
Hello, Abhishek.
Good afternoon, sir.
Good afternoon, Abhishek. How are you?
Fine, sir.
Let me start with the basic questions, very basic questions I'm taking. Fine. So can you explain me what is resonance?
So resonance is an electrical phenomena. Actually, resonance is a natural phenomena whenever there is a two energy storing elements. The response is just in phase with the cause. So in terms of the electrical engineering, whenever we have two energy storing elements like inductor and the capacitor, then the current in the circuit become in phase with the voltage. So this phenomena is known as the resonance phenomena.
Okay. So assume that I'm not an electrical engineer. Then how you are going to explain me the concept of resonance? Anything related with the frequencies and all? It's a natural phenomena. It's not only linked, not only linked to electrical, it is linked with other systems also. In mechanical also you can get the resonance.
Yes, sir. Yes, sir. Sir, suppose we have a spring and we have some mass system. So there is a transfer of the energy at one particular frequency. Like that, the energy stored in the spring is get converted to the motion of the mass, and sometimes the motion of the mass is getting is stored in the spring energy. So this is like a resonance phenomena in that.
Okay, fine. Can you explain me what is a tank circuit?
The tank circuit is nothing but the combination of inductor and the capacitor. In the tank circuit, the inductor and capacitor are parallel to each other, and resistance is very, very less in the tank circuit.
Okay.
And at the resonant frequency, the impedance offered by the tank circuit is infinite.
Is it infinite or zero?
Sir, it is infinite.
So from where you are measuring? Two elements are in parallel. One is inductance and the one is in capacitance.
Yes,
so in
sir.
fact, we have to take it as inductive reactance and capacitive reactance.
Yes, sir.
At resonance, both values are equal.
Yes, sir.
Are you taking the parallel combination of those two?
Yes, sir. Parallel combination of the L and C.
Okay. Yeah. What does it mean by damping?
Damping means, sir, in reference to the control system, whenever the response is there, it's like oscillating. The response is oscillating, and at the during transient state, and at the steady state, it reaches the desired output, or it approaches the desired output. So during the transient period, it made a various oscillation, and ultimately this oscillation damps out. So this is known as the damping.
So assume that, again, I'm a layman, I don't understand control systems and all, then how you're going to explain to a new student what does it mean by damping?
The damping means that in measurement also, wherever we have when we measure any quantity, that the needle at the fine destination position oscillates about that position. So that fluctuation or the needle is that nothing but the damping there.
Okay. So can you explain about loading effect? What is loading effect?
The loading effect is the effect or the effect of the instrument that is connected for measuring any quantity. Suppose we connect a voltmeter, then the error that is being produced by the voltmeter due to its resistance is known as the loading effect of the voltmeter. And if we connect an ammeter, then the error that is produced by the connection of the ammeter is known as the loading effect of the ammeter.
Okay. An ideal voltmeter must have how much internal resistance or how much resistance?
Infinite.
Okay. If it is infinite, then it is an open circuit. No current will flow. Meter will not work. I think.
So that is the case. In ideal, actually, the ideal voltmeter is assumed to be infinite, but since when it is infinite, it will be open circuited. That is why we just put a very high value of the resistance across the voltmeter.
Okay, how to achieve high value of resistance practically?
High value of we just connect it across that. We can use any material which have very high value resistance.
Okay. Any method you saw from electronic circuits? Any device of electronics you're using which is having high input impedance? Any idea on that?
Sir, any device, if I just talk about the MOSFET or IGBT, these have very high input impedance.
Okay. So let's move to electronic side. Okay, let's throw some light there. I have an operational amplifier whose gain is 10 to the power of 6.
Yes, sir.
And the input is 0.1 volt. Then how much will be the output? Output voltage.
So it all depends upon the connection, that whether we have the feedback or not. Suppose we don't have the feedback, then the output will saturate, that it will be saturate to the supply that we have provided. And if we have some feedback, then only the amplification can be done.
So see, I'm giving the voltage also plus VCC is 15 volts, minus VCC is minus 15 volts. My input voltage is 0.1 volt. Then with feedback, can you tell me how much will be the maximum output voltage I can achieve at the output side?
So with feedback, it can be the 10 to the power 5.
10 to the power of 5. Okay.
Yes, sir.
Fine. Yeah. Now, what is the difference between network and mesh?
Sir, network is a combination of the electrical component which may or may not be closed. But a mesh is a combination of the electrical network which is closed. And there is no any multiple loop in the mesh. Mesh is the single loop.
Okay. So actually my question was, what is the difference between mesh and loop? It was
Okay, sir.
misread actually. Yes, mesh and loop, not mesh and network.
Actually, the mesh is an electrical circuit which does not have any further loop in that, and the loop may have any internal loop, any other internal loop in it.
What does it mean by line commutation?
The line commutation is the commutation technique of, or you say the line commutation is the method of turning off the thyristor in which the supply supports the commutation process.
Okay. So in power electronics, we have rectifiers, inverters, stoppers, and cycloconverters. So what are all those which are by line commutation or natural commutation?
Those are not all the devices in the power electronics are commutated by the line commutation technique.
Okay.
Especially when we have a AC voltage source on the input side, we can have the facilitator of using the line commutation. And when we have a DC source like in the choppers on the inverters, there will be the force commutation technique which for the commutating the thyristors or devices.
Okay, fine. So can you define time constant?
So time constant in reference to the RC circuit. Suppose we have an RC circuit and we have applied a alternating voltage source across it. Then the time constant can be defined as the time taken by the capacitor to charge about 63.2% of its maximum value is known as the time constant. And in reference,
you are saying that you are going to give alternating voltage source to the RC circuit. Then
no, sir, sorry, no, sir, DC voltage source. Sorry. When we provide a DC voltage source across the RC circuit, then the time required for the capacitor to charge up to 63.2% of its maximum value is known as the time constant. Okay. And the time constant for the RC circuit is given as RC, and time constant for the RL circuit is given as L upon R.
Okay. So when it comes to voltmeters and ammeters, analog voltmeters and ammeters which are used in laboratories or in industry, there is a needle pointer, okay, which is reflecting from 0 to the value what we are giving. Okay. Yes, so sometimes the pointer will oscillate a lot. Sometimes the I can say pointer is very slowly moving. So what could be the solution, and in which way we have to design this system in such a way that it's not going to oscillate too much, or it is going to be very slow? So can you throw some light on that?
Sir, in measurement, when the needle approaches to its desired value, it oscillates before settling at the final position. So it is a good indication. It's a second order system. Basically, any measuring instrument is a second order system whose zeta value lies in between 0.6 to 0.8. But whenever we have zeta is equal to 1, we can have a critical damping, we say, and the pointer or the needle just settles on the final value. So if in some cases there are some lot of oscillation there, so we can just provide them extra damping by connecting a resistor in the instrument so that it can have a less amount of the damping in that.
You said that by using damping ratio theta, so which is having less time constant, not time constant, settling time, under damped or critically damped?
It is critically damped, sir.
Then why can't we use critically damped? Does critically damped is going to have any oscillations, or it is going to produce any oscillations?
No, sir. It will not produce any oscillation, but the pointer will go in a one way to the final position.
And what's the problem with that? Let it go. It is going to reach the final value within less amount of time, and it's not making any oscillations. Then what's the problem with critically damped system? Critical damped system type taking is less when compared to under damped, right?
Sir, actually, it is not desired to have. Sir, I'm not getting it right, sir.
Okay, fine. Let me give you feedback, Abhishek. Good, you are technically good, but let me give you feedback on few questions where the answer is mixed from you. See, I asked about resonance. See, resonance is a phenomena where input frequency is equal to system natural frequency, whatever may be the system. It may be mechanical, electrical, or whatever it is. You are providing some input. System is having some natural frequency. Every dynamic system from second order, okay, is going to have some natural frequency. If that frequency is equal to input frequency, then a phenomenon will occur in the system that is called as resonance. Okay, yeah. And after that, I asked about tank circuit. That's fine. Okay. Then, yeah. So with feedback, there is an operational amplifier. Input resistance is R1. Output feedback resistance is R2. And the gain will be minus of R2 by R1. I am taking one more amplifier, operational amplifier in cascade. Then whose resistance are equal. Then it is going to give a gain of -1. Final gain is V0 is equal to R2 by R1 into V8, right?
Yes, sir.
So that is having feedback from output to input. Okay. Yeah. Then I'm giving 0.1 volt. Plus VCC is 15, minus VCC is minus 15. I'm giving 0.1, and the gain is set 10 to the power of 6. If I say we never get 10 to the power of 5 volts, it will saturate to plus 15. Okay, never it is possible.
Yes, sir. Yes, sir.
It will saturate to 15 volts only.
Yes, sir. Yes, sir.
That is one thing. And a damping. See, damping is a very simple word that is opposition for the oscillation. Opposition is the main word we have to use. If there are oscillations, those oscillations are opposed by something that is called as damping. Okay, so we have a damper winding in electrical machines also, right?
Yes, sir.
Yeah. So how to achieve high resistance? By using, mostly these days we are using electronic components like MOSFETs and IGBTs, whose input resistance is very, very high. Those we are using for achieving high resistance in the measurement purpose. Okay.
Okay.
And see, loading effect also, see, you are taking always measuring purpose, and you are explaining that, yeah, what you explained is perfect. But see what is loading effect, as sir told, that is whenever you are introducing a meter, that meter is altering the existing circuit condition, which is not a wanted condition for us, which is not an intentional condition for us, right?
Yes.
So apart from these things, your feedback is good, and yeah, 90% of all the questions you answered correctly. Okay, over to sir.
Hello.
Yes, sir.
देखो आपकी नॉलेज मेरे को टेस्ट करनी थी, बेसिक नॉलेज आपको अच्छी है, ठीक है, आई गोट द आइडिया, ठीक है, लेकिन थोड़ा सा ना आंसर करते हुए जल्दी नहीं करना, ठीक है, थोड़ा सा सोच के आंसर करना। कुछ छोटी छोटी चीजें होती है, टू बीइंग ए टीचर यू हैव टू बी क्या बोलते हैं एक्स्ट्रा कॉशियस, कि जो आप बोल रहे हो वो कोई भी ऐसा ना हो कि जैसे क्या वर्ड बोलते हैं उसको, कैजुअली आपने बोल दिया कि वीएम होता है सर, ठीक है ना, तो मैंने पूछा वीएम ऑफ व्हाट। हेलो,
यस सर, यस।
हाँ, तो आपको प्रिकॉशन लेके, इजी क्वेश्चन है लेकिन आपको क्या करना है, थोड़ा सा कॉशियस होकर वीएम ऑफ लाइन वोल्टेज, ठीक है ना, हाँ बस, और सब चीजों पे नॉलेज आपकी ठीक है, उसमें कोई डाउट नहीं है, ठीक है, उसके हिसाब से मेरे को ठीक लगा। इंस्ट्रूमेंट एक्यूरेसी ये सब वो है, 2 वाट मीटर से क्वेश्चन जरूर पूछे जाते हैं। डैम्पिंग, डैम्पिंग जो हम कंट्रोल में पढ़ते हैं, डैम्पिंग बेसिकली एक्चुअली प्रैक्टिकली इंस्ट्रूमेंटेशन में करते हैं, एयर फ्रिक्शन डैम्पिंग, ठीक है ना, और फ्लूइड डैम्पिंग, और एक एडी करंट डैम्पिंग, ठीक है ना, इससे रिलेटेड भी क्वेश्चंस आपसे पूछे जा सकते हैं, ठीक है। और मशीन में भी आपने जो मैं बेसिक पूछना चाह रहा था कि बेसिक नॉलेज होनी चाहिए, वो आपको है उसमें, ठीक है, कोई वो नहीं है। लेकिन कोई भी चीज जैसे क्रिटिकल रेजिस्टेंस, ठीक है ना, वो क्रिटिकल रेजिस्टेंस स्पीड पे जरूर डिपेंड करता है, तो जिस पे डिपेंडेंसी होती है उसको बताना जरूरी होता है, ठीक है। ठीक है अभिषेक, गुड लक, और मेरे हिसाब से आप ठीक है, कोई प्रॉब्लम नहीं, इतना होता है इंटरव्यू में, इतनी थोड़ा बहुत इतना वो होता है, ठीक है, जस्ट गुड लक, ऑल द बेस्ट।
Thank you, sir.
Okay, Abhishek, so when is your interview?
Ma'am, tomorrow.
Tomorrow, right? So there are certain things you just need to remember. You are very good in English. Don't need to worry about it. Your explanation is good. थोड़ा सा nervous नहीं होना. Try to smile at the very start and end. Okay? Don't be nervous. एक चीज को ना repeat मत करो. आपने 2-3 बार बोला, जैसे good in English, good in मतलब कि good in explanation, है ना? वो चीज की जगह बोल सकते हो कि आपने एक बार बोल दिया good in explanation. Then you have empathy with the students. आप स्टूडेंट्स के साथ बहुत अच्छे रिलेशन रिलेट कर पाते हो, मतलब वही चीज को बोलने के तरीके को डिफरेंट डिफरेंट कर देना। रेपिटेशन मत रखना, वो क्या होता है, वो स्ट्राइक करता है कि बच्चा एक ही चीज को रिपीट कर रहा है। ओके। और एक क्वेश्चन जब मैंने पूछा था कि पीएचडी क्यों जरूरी है ना, आपको लगता है पीएचडी वाला अच्छा पढ़ा सकता है, तो से फॉर इट कि मैम पीएचडी वाला रिसर्च अच्छी करवा सकता है, बट पढ़ाने के लिए पीएचडी इज नॉट इम्पॉर्टेंट। उसके लिए आपको एक अच्छा लर्नर होना चाहिए, एंड आई एम अ वेरी गुड लर्नर। आई डोंट थिंक पीएचडी कैन रिस्ट्रिक्ट टीचिंग, या पीएचडी इज एसेंशियल टू गो फॉर द रिसर्च एंड ऑल। ठीक है, तो दैट वाज द वन थिंग। वन वर्ड आपने अपने लिए डायनामिक चूज किया, go for any good word. ठीक है, there are number of words, practical, social, amiable, you are very dedicated, passionate, है ना, तो आप वो अपना एक वर्ड अच्छा चूज कर लेना अगर आपने अपने आप को एक्सप्लेन करना है। you're a good learner, even that can be a word, you are a smart learner, ठीक है। और बाकी आपका I don't think there was only 2 things I found something wrong in you. Why not PhD? It was the question. So for that you have a financial issues and all that, and you wanted to become financially independent first, and then go for this. You will go for PhD, but not right now. So have a diplomacy. Okay, chalo. And one last thing, whenever they ask you why teaching, क्यों choose किया था हमेशा, in case they ask you this question, go for it कि मैम मुझे teaching किताबों से जुड़े रहना अच्छा लगता है. I want to do teaching because I am a very good learner. I can learn everything, something new. और मुझे अपने बिहार के स्टूडेंट्स को, आगे बच्चों को, यंग बर्ड्स को सही डायरेक्शन में ग्रो करवाना है. ठीक है, तो I want to contribute in it. Rest is fine. All the very best and keep smiling. Okay. Yeah. Okay. Take care.